Another day, another problem, so let's solve it. Hello guys, I hope you are all doing well. So today in this video we're gonna solve the problem, delete columns to make sorted. So let's get started. So the problem is that they give us an array of strings and they ask us to delete a minimal number of columns from the list such that each remaining column is in lexicographic order, means alphabetically sorted. For example, let's say we have this list of strings. The strings can be arranged such that there is one on each line, making a grid. So they ask us to write a function that takes a list of strings as an input and return the minimum number of columns that need to be deleted in order to make the list of strings lexicographically sorted. So to solve this problem, we're going to initialize a counter that's going to count the number of deletions that need to be done to make the list of strings sorted. Then we're going to start iterating throughout the columns of the input list and group the characters from each string into one tuples. Then compare these tuples, means the columns, to the sorted version of these columns. If it's not sorted, we increment the deletion counter by 1. After all the columns have been processed, we will return the total number of deletion needs to make the list of strings sorted. So let's jump at coding the solution. First, we initialize counter called deletion to be 0. This counter is going to be the number of deletion needed in order to make the list sorted. Then we start iterating throughout the input list. We're going to use the zip function to group the characters from each string into tuple, and we're going to use the asterisk operator to unpack the element of the input list as separate argument to the zip function. For each column, the function compares the original column to a sorted version of the column. If the original column is not in sorted order, the counter is incremented by 1. After all columns have been processed, the function returns the total number of deletion needed. So to make the code more smaller, we can just write it in one line with the help of the sum function that's gonna return 1 for each true statement. So if the corresponding columns in the input list of strings is not in sorted order, we return false, otherwise we return true. So the function uses the sum function to sum up the list of boolean values as a 1 and 0 as a false. Then the resulting sum is returned as the output of the function. So the time complexity for this solution is O of n multiplied by m, where n is the number of strings in the input list and m is the length of the longest string, because the solution iterates throughout all the strings and all the characters in each string. So the time complexity is linear in the size of the input. And for the space complexity is a constant time, means O of 1. Thanks for watching, see you in the next video.